Welcome back. This is Professor Ridge, and today's lesson in section 8.2, Arithmetic Sequences and Series. A sequence is arithmetic if there exists a number d, called the common difference, such that a sub n plus 1 equals a sub n plus d for any integer n greater than or equal to 1. Now, again, a lot of people see a sequence like this. Example. So let's say I started with a number, say like 5, and I wanted to get the next term, the way you read this, to get the next term, this a sub n plus 1. So this is a sub 1. The next term would be a sub 2. So a sub 2 would be a sub 1 plus some number. So let's choose d to be 3. So 5 plus 3 is 8. And to get the next term, you're going to do 8 plus 3, which is 11. So kind of like defining it recursively. So if we keep adding the same number, A4 would be 14, because you're going to add 3. Add 3 again, that would be 17. Add 3 again is 20, so on. So see, this sequence would be arithmetic, and the way you can check it is, the way we built it is we're adding 3 to get the next term. You just add 3 to the term you're on. Right, and again, the reason it's called difference, if we did algebra and solved this formula for b, right, so if I said solve for b, just doing some straight algebra, you're going to subtract a sub n from both sides, and you get a sub n plus 1 minus a sub n, which is a difference. And so that's why it's called the common difference. So if I ask you to find the common difference, you just pick any two successive terms and subtract them. And it's the latter one minus the one that's right before it. Okay, so find the first term and the common difference of the given arithmetic sequence. So basically the first term, that's easy. A sub 1 is just given to you right there, is 3. And then find the common difference, you're going to just take a sub 2 minus a sub 1. Or you could do a sub whatever, say a sub 3 minus a sub 2. Or a sub 4 minus a sub 3. It doesn't matter, just pick two and subtract them. They have to be right next to each other. So I'm going to do a2 minus a1. So that would be 9 minus 3, which is 6. So our common difference is 6, and the first term is 3. Okay, so it's pretty straightforward, nothing fancy here. So what if we had this one? 3/5, 1/10, negative 2/5, so on. So a sub 1 would be the first term is 3/5, and d is going to be a sub 2 minus a sub 1, which is 1/10 minus 3/5. So that would be what, 6/10, which is negative 5/10, which is negative 1/2. Okay, so let's look at this example. Find the 12th term of the arithmetic sequence given a sub 1 is 7, and d is 3. Now again, one way we could do this is we can just build the sequence. Well, a sub 1 is 7, a sub 2 is 7, is a sub 1 plus b, which is 7 plus 3, which is 10. A sub 3 is a sub 2 plus d, which is 10 plus 3, which is 13. So a sub 4 is 13 plus 3, which is 16. A sub 5 is 19. A sub 6 is 22. So we're just adding 3. So that's 6. a sub 7, a sub 8, a sub 9, so we're going to add 3, 25, 28, 31, sub 10, a sub 11, a sub 12, that's 34, 37, and 40. So a sub 12, so the 12th term is 40. Now, if I ask the same question, but I want to find the 100th term, you definitely don't want to do, build the whole sequence of there. So let's see if there's a shortcut. Okay, so the same sequence, we want to find the 100th term. So again, I don't want to, I already got A12 is 40, and then it'll be 43, so on. But let's see if we can figure out a shortcut. And the idea is, since we're adding b to the previous term, so look at a sub 3 would be a sub 2 plus b, but we know that a sub 2 is a sub 1 plus d, which gives us a sub 1 plus 2d. And then a sub 4 is a sub 3 plus d, but we just found out that a sub 3 is a sub 1 plus 2d plus our other d. To get a sub 4 would be a sub 1 plus 3d. And then pretty soon you start seeing this pattern emerge. So a sub 4 plus d is a sub 1 plus 3d plus the d. You get a sub 1 plus 4d, and then you should see this pattern. We're getting a sub 1 is a sub 1 plus 0d, a sub 2 is a sub 1 plus 1d, and then a sub 3 would be plus 2d, plus 3d, plus 4d. So a sub 6 would be a sub 1 plus 5d, and then we can make this general term a sub n is going to be a sub 1 plus 1 less than whatever n is, d. So if we're at a sub 100 is going to be a sub 1 plus 99d, which is going to be 7 plus 99 times 3, and punch that in your calculator and you get 304. And that's a lot quicker than trying to do, build the whole sequence up to the 100th term to figure out what the 100th term is. We want to look for that formula. Okay, so we're going to kind of, I'll rewrite this here. That's our formula for the nth term. Okay, so let's do another example. Find the 17th term of the arithmetic sequence. Okay, 7, 4, 1, so on. So we can see that a sub 1 is 7, d is 4 minus 7. Now remember, you got to do a2 minus a1 or a3 minus a2, either one. And that gets us negative 3. You got to do it the right order so you don't get the sign wrong. And you can see if you subtract 3, you get 4. 4 minus 3 is 1. So our common difference is negative 3 because we're going to subtract 3, not add 3. Alright. So we want to find the 17th term. We're using the formula we just read above. A17 is a sub 1 plus 1 less than 17, so that would be 16d, and d is negative 3. So that's going to give us 7 plus 16 times negative 3, and punch that in my calculator, and I get negative 41. Or punch it in your calculator. Alright, so that's how you find the general term, if you know a sub 1 and d. Okay, let's try an example to find d if you know the first term and the 11th term. So we're going to use this formula a little differently. Okay, but we still use the same formula. A sub n is a sub n is a sub 1, sorry. Let me write that again. A sub n is a sub 1 plus n minus 1 d. We want to find d, so we know that this is a sub 11 is going to be your a sub n when n is 11. So we're going to plug that in. 26 equals a sub 1, which is 8, plus 11 minus 1 d, and you're going to solve this equation for d. Okay, so we're going to use a sub 11 is 26, so we put 26 for a sub 11, and 11 is the n, and we know a sub 1 is 8. And again, we just solved this equation, so it's just a basic algebra question now. Subtract 8. Let me write it over here. So that's going to give me 18 equals 10b. Divide by 10. So d equals 1.8. Or if you want to use a fraction, be 9/5. This is a little more challenging. So in arithmetic sequence, you're given A17 is negative 40. So 17th term is negative 40, and the 28th term is negative 73. So find A sub 1 and D, and then write the first 5 terms of the sequence. Okay, so we're still going to use this formula, A for the general term. A sub n equals A sub 1 n minus 1 b. And basically we're going to do like the last problem, and we're going to use the, think of this as like 2 points. So A sub 17, so if I use A sub 17 equals negative 40, I'm going to plug that in to the general equation, and that's going to give me negative 40 equals A sub 1, I don't know. N in this case is 17, so it's 17 minus 1 b, which I don't know. And then I'm going to plug in the other terms. A28 is negative 73, and do the same thing. So negative 73 equals A sub 1 plus 28 minus 1b. And then from here, treat it like a system of equations. Let me simplify it. So I got negative 40 equals A sub 1 plus 16b. So think of that as my equation 1. And my equation 2 would be negative 73 equals A sub 1 plus 27b. And then I'm just going to solve the system of equations. Let's take equation 1 and multiply it by negative 1, which gets me 40 equals negative A sub 1 minus 16d. Equation 2 we'll leave alone. And you get negative 33 equals, see the A sub 1's cancel, and we get, what's that, 11d? 11d. Then we solve for d. So divide both sides by 11. D equals negative 3. So now we know D is negative 3, and plug this back into equation 1 or equation 2, doesn't matter. So I'll put it in equation 1. Negative 40 equals A sub 1 plus 16 times negative 3. That's negative 48. Add 48 both sides. So A sub 1 equals 8. So now I know that A sub 1 is 8, D is negative 3, so that's the first part. And then the first 5 terms would be, you start with 8, add negative 3, so that's 5, add negative 3 is 2, add negative 3, negative 1, negative 4. Okay, so there you go. Find the sum of the first 100 term sequence, 1, 2, 3, 4, 5, 6, up to 100. So again, we've talked about series before, so it's just the sum of all the terms of the sequence. Or in this case, it's the partial sum, so it's up from 1, the first 100 terms we're doing, so 1 to 100. So 1 plus 2 plus 3 plus 4 plus dot 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 plus 97 plus 98 plus 99 plus 100. Now, the thing to notice, if you take the first term and the last term, that equals 101. And then you look at the second term and the second to last term, that equals 101 also. Oops, 101. And then 3 plus the 98, that's 101. And then the 4 plus 97, that's also 101. So you get all these pairs, and then 5 and 96 is 101, 6 and 95 is still 101. And it turns out that all the pairs, so there's going to be 50 pairs of 101. So the shortcut to do this is you go 50 times 101, which equals 5,050. Okay? And it turns out that that works for any arithmetic sequence. I'm not going to show you, how to derive it, but the idea is it always works. So if you have, well, let me write the formula down. We'll do a couple examples. Okay, so S sub n equals n divided by 2. Now note that gives you the number of pairs. And then you just do the first term plus last term. And that's going to give you what all the pairs add up to. So whether it's the second term, second last term, third to the last term, or the first term and the last term, they all equal the same. And that works with the arithmetic sequence because of the way you're adding D. But anyway, so the tough thing then is to figure out the number of pairs, which, well, you just divide by 2. And then note, I always get asked this question, well, what if you only have an odd number of items? And then when you divide by 2, what happens? And that's a great question, because look at this. What if we did 1 plus 5 plus 9 plus 13 plus 17? Notice that the pairs, that's one pair of 18, another pair of 18, and then you got this 9 all by itself. So that's 2.5 pairs, or 5 halves, of 1 plus 17, which gets us 2.5 times 18, which is 3645. So it works. It's okay because 9 is half of 18, so we got 2.5 pairs. And it doesn't matter what the arithmetic sequence is, whether you have an odd number of terms or even number of terms, you just take n divided by 2, and that's the number of pairs. Whether it's a half pair or a whole, doesn't matter. It works out, and you're fine. So you don't have to worry about the odd case and the even case. So find the sum of all the multiples of 4 that are between 14 and 523. So multiples of 4 are 4 times 1 is 4, 4 times 2 is 8, 12, 16, 20, 24, so on. Now we want it between 14 and 523, so we got to figure out what's the last multiple that's of 4 that's less than or equal to 523, and it turns out it'll be 520. So we're going to go up to 520. And then if we're going to do this partial sum, we need to figure out what n is. We know what a sub 1 is and a sub 2. A sub 1 is 16 and a sub n is 520. So our first thing is, well, what's n? So if a sub n is 520, find n. We need to know how many terms there are so we can figure out how many pairs. So let's see, we do the same trick. We use the other formula. A sub n is a sub 1 plus n minus 1 d. So we got 520 equals a sub 1 is 16, n minus 1 d is 4, because we're adding 4, that's multiples of 4. So let's see, we solve this, that's 504. Now instead of distributing the 4, divide both sides by 4. So 504, that would be 126. And n minus 1, add the 1, it's 127. So n is 127. And we plug it into our formula, and look, we've got an odd number here, but we don't care. 16 plus 520, so that's 127 halves times 536, or 127 times 536 divided by 2, and that gets you 34,036. Okay, let's look at this one with the summation notation. So remember, the sigma, you can read it as sigma or summation. It's the summation of 2,000 minus 3k from k equals 2 to 50. So remember, k is our index variable. So we're going to start with the bottom number, which is 2. Put it in for k. You index it, meaning you add 1 to it. So now the index variable goes up to 3. So we go 2,000 minus 3 times 3. Index it. Goes to 4. And I really don't need to show anymore. Just the last one's all the one that I'm concerned with. So 2,000 minus 3 times 50. We're going to end at 50. So we get 2,000 minus 6, which is 1994. 2,000 minus 9 is 1991, plus dot 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 to 2,000 minus 150 is 1850. And now you could see that, right, a sub 1 is 1994, d is 3, and we want to find s sub n. So now it's just like the problem we just did. First we got to figure out what n is. Do the same trick that we did up there. So let's see. Oh, actually, no, that's not true. It's easier to find n because we're doing the summation. We're starting at 2, going to 50. So that tells us if we start at 1 to 50 would be 52 terms, but we're starting at 2. So the way you do it is you subtract the limits. So n is going to be the 50 minus 2, which is 48, but you have to, that's not counting 2, so you have to add that one back in. So you just have to add 1 whenever you subtract the limits. So 50 minus 2 is 48, plus 1 is 49. Okay, so there's 49. And again, just if you don't believe me, if you started at 1 and you went 1, 2, 3 up to 50, that'd be 50 terms. But when you go 50 minus 1, that's 49. So because you're not counting the 1, so you have to add it back in. So same idea here. Okay, so let's plug this into our formula. S of 49 equals 49 divided by 2. A sub 1 is 1994. We don't care about D right now, but A sub n, or 49, would be 1850. And we just plug that into our formula, or calculator. 49 halves times 1850 is 94,178. Okay, so that completes the lesson for 8.2. Go to my math lab, complete your exercise there, and I'll see you next time.